Good afternoon, everyone. My name is Anna Vinnedge, and I'm going to be talking to you guys about my research in predicting success in the Ranger Assessment and Selection Program. So a quick agenda, I'm just going to go through some background and motivation, the methods in my research, results analysis, and then some future steps and implications. So I want to start off by posing a question to you guys. Have you ever wondered if you could accomplish something really challenging before you even started? I know I definitely have. I'm seeing a lot of head nods. So that's essentially what my research is trying to show for a specific challenge, which is RASP, the Ranger Assessment and Selection Program. This is a 8-week-long course that takes place at Fort Benning, Georgia, that lower enlisted soldiers have to pass in order to become a member of the 75th Ranger Regiment, which is a special operations unit that's very elite, difficult to get into. And this course is really physically and mentally challenging and sits only at about a 35% pass rate, which is one of the lowest of courses in the Army. So I went out there last summer and talked to the people at the Ranger Regiment, the command team at RASP, and was posed with a few questions. Can we predict who will pass RASP using statistical models? Which out of those models perform the best? And then out of those models, what factors are the most important in predicting success? So given those questions, I decided to make two different statistical models. The first being a penalized logistic regression model, which is a version of a standard logistic regression that predicts a binary outcome, and it imposes a penalty for having too many variables. That this gets at some of the overfitting problems, and it's more interpretable. And then the second model that I decided to make was a machine learning random forest model, which we had described pretty well a little bit earlier, but just to review, it's a way of averaging multiple decision trees by taking the mode of several outcomes from these trees. So I started with a huge data set given to me by the Ranger Regiment, starting about 12,000 entries of 370 variables that included physical fitness scores, academic and IQ scores. And most importantly, we had a large array of psychometric data, so psychological factors like character traits and things like that. These are all de-identified for this project to maintain integrity and equity in future candidates, but the identified variables are provided to the Ranger Regiment. So with that data set, I went through a pretty extensive cleaning process. There was a lot of missing variables. We removed all of the missing entries from the psych data because that was kind of one of our most important focuses. We also removed any variables that occurred after the start of RASP, since we were looking at predicting before anyone even began. We set some defaults. So like, for example, there were missing entries in languages spoken. We assumed that everyone spoke at least English at a minimum, put that in and did that for a few variables. And then finally, we went into a correlation analysis to drop variables that were really highly correlated. So we did this using a Pearson correlation coefficient, which is a bivariate linear correlation measure. And we made some trees to look at variables that were very highly correlated, broke those trees down into these heat maps and looked for any correlation that was greater than 0.8. And out of those two, we would drop one. This just worked on the problem of minimizing overfitting and remove some redundancy in our results. So before running the models, we determined two performance metrics that we were going to look at. The first being accuracy, which just uses your like true negative, true positive assessments. And accuracy is determined by the number of correct assessments made by the model over the number of all the assessments. And then the second measure we used comes from the receiver operator characteristic area under the curve. So that's a curve with sensitivity on one axis and 1 minus specificity on the other. Sensitivity, kind of like we heard earlier, that's the number of true positive assessments over the number of actual positive values. And then specificity is the number of true negative assessments over the number of actual negative values. So using this, we threw our data into those two models and looked at how they were performing. The top is that rock curve, and you can see that the area under the curve of the random forest model is greater. So that means that there's a greater ability to distinguish between classes for the random forest over that penalized logistic regression. And the random forest also showed us a slightly higher accuracy value of about 0.8. So we moved forward with our random forest model and used variable important plot to rank our most important variables. This graph is our top 20, and how this selects your most important variables given a random forest is it looks at single predictors and maximizes some measure improvement, and you get like our top score. For those of you who don't know, APFT is a Army fitness assessment. So we see that's almost doubly important as some of the follow-on variables, but we have a lot of the psychological factors show up, as well as some of the IQ and written evaluations. So in our analysis, we also did some breakdowns by racial minorities and military occupational specialty, or basically like your job in the Army, and to see if there are any patterns that emerge specific to different subgroups or groups that the Ranger Regiment is trying to bring in more heavily. One thing that we saw was that there were more psychological variables in racial minorities appearing higher up in these rankings than in the overall models. So these models aren't necessarily meant as a tool to eliminate candidates who might be at risk of failure, but they are useful for informed data-driven decision-making. They can help identify candidates who might need to go through additional screening or additional training that could help improve their probability of success. This could give an economic benefit to the Ranger Regiment, because if we're getting more people through who are more likely of passing, you can spend less money getting people like halfway through before they drop. And then very importantly, it can be used as a recruiting tool. This is one of the priorities of the Ranger Regiment, to bring the right people in, especially in those underrepresented groups like racial minorities, the military occupational specific recruiting, and eventually looking, once we get more data with females, trying to get females into these special operations sections of the Army. So key takeaways from this project: useful for the Ranger Regiment, but even more than that, this is a demonstration that machine learning models like this can be applied to a wide range of tasks and jobs. They help us understand the traits that are important for mission success. So this gets after a very wide range problem of getting the right people, trained the right way, and into the right jobs. If you want to hear more, I will have a poster and link to a paper, and I'd be happy to talk to you about it. Thank you.